Hello, John Paulson with JDE Resource Services, here to present an overview of the JD Edwards Orderless manufacturing application. First, let me tell you a little bit about myself. I've been consulting on JD Edwards manufacturing applications for a little over 20 years now, and my prior professional life's been in manufacturing management for Northwest manufacturers. Orderless manufacturing is an exciting topic for me. I think it's the coolest application in the JD Edwards manufacturing module. Why? I've seen some awesome re-engineering of processes in manufacturing with the Orderless application. When I bring up the topic of Orderless and its functionality, it gets the wheels turning with those in manufacturing to really rethink their processes. Whether it be for a full product line or fabricated assembly, Orderless can streamline the process. Now, Orderless certainly isn't for every manufacturing environment, but for those who are running repetitive manufacturing, it is certainly worth looking at. You look to see where the application is a fit, design a proof of concept, test it out. I find in many cases, Orderless is a catalyst for further lean improvements to operations. Essentially, with the JD Edwards Orderless manufacturing, there is no work orders to manage. Let's look at a scenario. Manufacturing Scenario 1, displayed here, is a low complex process for the purpose of explaining how JD Edwards Orderless can be applied. However, it does represent a real-life scenario that played out for implementing Orderless. Scenario 1 is a high repetitive product, short cycle time, which is an ideal fit for Orderless. The top left box, Step 1, is the demand. This is where it all starts. This could be based on a customer sales order, production plan, or other. Demand is processed through the Material Requirements Planning System. The output of the MRP will be the work order requirements, along with the purchasing requirements. Steps 2, 3, 4, and 5 is where it all starts with the work order preparation. Creating the work order from MRP messages, attaching the parts list and routing, printing, then off to engineering for drawings, work instructions to include in the packet. Then, Step 6, the work order packet is moved to the warehouse for parts picking. The work order will most likely have a queue time. After parts pick, then to Step 7, the work order is moved to the staging area in manufacturing. More queue time. The work order will then move from operation to operation in manufacturing. To work order completion, Step 14. At work order completion, there will be an entry into the JD Edwards system. The process completes at manufacturing accounting with GL Post, Step 15, along with finished goods movement to the warehouse for shipment. The actual scenario was a computer accessories product line with stable demand running a rate of about 1,300 a day. I chose this scenario for simplicity to better explain the Orderless application and how it can be applied working with the typical life of a work order. Now, let's look at the scenario with JD Edwards Orderless. Scenario 2 displays the application of the JD Edwards Orderless manufacturing system and changes to the process from Scenario 1. As you can see, quite a dramatic change to the process has taken place. Really, we are moving in a very lean direction for manufacturing with this change. Now, understand this one size certainly doesn't fit all, but the purpose is to generate ideas of how you may be able to apply JD Edwards Orderless and lean applications to your manufacturing environment. Again, this particular scenario is of a high volume product line, repetitive manufacturing. This could be a 2, 3, 4 model number mix, and short manufacturing cycle time. Okay, starting with Step 1, we are able to eliminate the demand messages driven by MRP. For component purchases, we have the options of working with vendor-managed inventories, Kanban, reorder points, utilizing the JD Edwards PO generator or suggested reorder stock item program. For work orders, we have the option of working with the customer forecast, the sales orders, creating a Kanban visual signal for shop floor for the daily requirements. This could be as simple as a whiteboard or workstation display terminal. With this scenario, we've just cut out much time in that work order process, in planning, creating, packaging up that work order, scheduling. So now, how does the warehouse know what to pick if they don't get that work order packet? The material movement process will now change to fit Orderless. No more picking that work order parts list. But now a steady routine of material replenishment to the work center staging area will take place. This is at step 7. Better yet, that replenishment will take place at the point of use on the work center assembly line. This could be based on a Kanban. Certainly options to work with here, such as handheld mobile alerts to the warehouse when the work center location drops to a reorder point level of inventory. A replenishment quantity alert will alert the warehouse for an inventory pull. This was actually set up recently for an auto parts manufacturer. The material handler said, this alert system is nice, but we'll probably rarely ever use it just because they're constantly feeding that line throughout the day based on visual cues. Steps 8 through 12, the assembly line will manufacture based on a Kanban amount or a daily rate to produce. The work instructions will be posted at the workstation or viewed on the workstation display terminals. Upon completion of the assembly process, step 12, is the entry into JD Edwards utilizing the JD Edwards Orderless ad hoc completions program, backflushing the consumed components, and a system issue of the completed assembly to the warehouse for shipping. When a completion is processed, it issues components to the manufactured end item. It updates the daily plan with actuals completed. It updates the daily plan with actual scrap quantities. It updates the end item inventory with finished goods. It updates the item ledger table and updates manufacturing accounting. With that system entry, all you are doing is entering the assembly number, the amount completed, and you hit that submit button on your handheld scanner. 3 steps. And you are eliminating the whole work order process. And on top of that is the streamlining of material movement. With JD Edwards Orderless, there is also the option to set up a daily plan if desired to manufacture to, or just run the ad hoc completions. Many benefits to moving to Orderless. Also understand that this doesn't have to be a full product line that you have to implement to. This application is usually more practical for a subassembly or fabricated part that's run continuously. Now, let's look at the transactions that take place in the system. First, we'll look at the product structure associated with the orderless completion that just took place. The parent assembly consists of 2 assemblies, Assembly 1 and Assembly 2. Both of those assemblies each have a purchased component reporting to them. When the completion takes place of the parent, the component is deducted from stock to the subassembly. The subassembly is entered into stock and back out of stock to the parent assembly, all within one parent completion. It's a backflush. Within the Transaction Management Inquiry program, the PF 31014, you can view the transactions. 3 primary identifiers: the production ID number, transaction ID number, and the master transaction ID number. The production ID number is based off the daily plan that's set up. The transaction ID ties to the parts issue, and the master transaction ID will tie to the parent item completion. Now, within the item ledger, looking at the parent assembly, we have a document type LC. This is for lean completion. That has the transaction date, the quantity, the unit cost. Next, we look at the subassembly. With the orderless, during the completion of the parent assembly, the system transacts the subassembly with a document type LC for lean completion, bringing that subassembly into stock, and then an LM, material issue, taking it right back out of stock to that parent assembly completion. So you got a quantity of 1 going in, quantity of 1 going out. Now, let's look at the transaction of the component to that subassembly. We have a document type LM for lean material issue of that component going to the subassembly. Has the date, the quantity, unit cost. So our completion for the parent will include the 2 subassemblies and the components below that. Again, it's a backflush that takes place. So that is the process of JD Edwards Orderless Manufacturing at a very high level. And hopefully this will generate ideas of where orderless may be a fit for your manufacturing environment. If you have any questions, or if you'd like to discuss setting up a proof of concept for your manufacturing environment, shoot me an email at jpaulson@jderesource.com. That's jpaulson at jderesource.com. Thank you.